Section 10.2, extra example number 4. A potato chip manufacturer buys potatoes from two different suppliers, Riderwood Farms and Camberley Incorporated. The weight of potatoes from Riderwood Farms are approximately normally distributed with a mean of 175 grams and standard deviation of 25 grams. The weights of potatoes from Camberley Incorporated are approximately normally distributed with a mean of 180 grams and a standard deviation of 30 grams. So the mean weight of the which population is bigger? Camberley is bigger. Okay. So when shipments arrive at the factory, inspectors randomly select a sample of 20 potatoes from each shipment and weigh them. Okay. So that's smaller than 30, right? But we're told the population is normally distributed. So they are surprised when the average weight of the potatoes in the sample from Riderwood Farms was higher. Of course they're surprised, right? Because the average of Camberley is higher. But the sample, this particular sample they took for Riderwood, was higher than the average weight of the potatoes in the sample from Camberley. So we're going to describe the shape center spread of the sampling distribution of the difference of means and from Camberley and Riderwood. And then find the probability that the mean weight of the Riderwood sample is larger than the mean weight of the Camberley sample. So should the inspectors have been surprised? Or should they be like suspicious that they're lying about the mean weight and standard deviation if that sample came out the way it did? Okay, so let's first describe the shape center spread of the distribution of the difference of means. So first of all, the shape is easy because it's going to be approximately normal, because both of the population distributions were approximately normal. So the shape of the difference, the distribution of the difference of the means, is approximately normal because both population distributions are approximately normal. Careful about ever saying exactly normal. Just kind of try to stay away from that in general. Approximately normal. Okay. Shape center is the center is the middle, the mean. So you just subtract the population averages. So you would just go like this for the mean of x bar sub c minus x bar sub r for Camberley minus Riderwood. We would just subtract these. So you get 180 minus 175. We're just subtracting the two means and we get 5 grams for our distribution. So there's the center, there's the middle. And then the spread is talking about standard deviation. So the formula is given on your formula card, and it's written as, on the formula card, the standard deviation of two sample means. You can't just subtract them. You have to go through the variance. So you have to square them and take the square root. And so the formula looks like this. Standard deviation over sample size for the first population, standard deviation squared over sample size, square root. That's what you would use. And so that comes out to be 25 squared over 20 plus 30 squared over 20. And so you get 8.73 grams for the standard deviation of the distribution of the difference of the means. So we know the center and the standard deviation. So that allows us to find the probability of getting a certain result by knowing that it's normal, and we know the center and the standard deviation. So for part B, we're looking at what we want is the probability that the difference is what? Is it greater than 0 or less than 0? X sub c minus x sub r. Is it greater than? So we want to know the probability that the Riderwood sample is larger than the So we want to know the probability that if we do it in this, we have to do it in this order because that's what order we used when we found the center and the standard deviation. So we have to keep this the same so that it matches the distribution. So would it be greater than 0 or less than 0, the difference? Less than 0, right. So we want the probability that the weight of the Riderwood would have been larger. So it's less than 0. When you do the subtraction, it would be less than 0. So it's really helpful to look at what's happening here. And so the center, we know, is at, we calculated earlier, is at 5 grams. And the standard deviation is 8.73. So let's, we're looking for less than 0. So we need to know where 0 is, and we want to shade everything to the left. So where about is it? Well, one standard deviation to the left would be 5 minus 8.73, which is negative 3.7, roughly. And then the second standard deviation, well, we don't even need that. The second standard deviation's there, but 0 is in here somewhere. So what we're interested in is, 0 is like somewhere around here, and we want to know this probability, which is equal to the area under the curve. So that's 0 is right here. So the probability that we get less than 0. And having a picture is helpful because right away the answer is about is less than 50%. So the answer is around 30% or something like that. 40%. So that helps you know that it's what's reasonable. So we just find the z-score. So we want to know how far away 0 is from 5 in terms of standard deviations. So you would just do how far away is 0 from 5 in terms of the number of standard deviations. So you just calculate your z-score. And so what we want to find is the probability that z is less than negative 0.57. So it's about a half standard deviation away from the mean. So on your calculator, you would do normal CDF from negative infinity up to negative 0.57. And that would give you 0.28. Or you use table A. So should the inspectors be surprised at their results from the samples? Is it possible that could have happened, that the Riderwood one could be larger than the Camberley? What's the chance that could happen? There's a 28% chance that it could have happened. So that's not surprising at all. That's more than a quarter. So you would say the inspectors should not be surprised. The inspectors shouldn't be surprised because the Riderwood sample would have a higher mean 28% of the time. Would have a larger weight. Well, a larger mean is correct as well. A larger mean 28% of the time. And that could definitely happen. If we said 1% of the time, then we would be suspicious. If we, somewhere between less than 5% of the time, now we would have a little bit of a hard time.